Hello everyone, welcome back to the new video. I'm the software engineer currently working at PayPal. So in this video I'm going to talk about the recursion. So this video I'm making for those people who have the difficulty in understanding the recursion. So I'm going to share some tips and the tricks so which you can use while solving the recursion problem. And after watching this video, I'm sure that you won't need to watch any other video. I hope your doubts regarding the recursion will also get solved. So initially, while learning the recursion, it is a little bit difficult to understand. First of all, understand about what is recursion actually. Recursion is calling the same function again and again. What does the function means? You might have already familiar with the function if you are studying the recursion because it needs to be studied before the recursion. So function is like we give some input in the function and it will return the output, and inside it have our processing. We can process anything what we wanted to do inside the function. Logical piece of entity which is solving a particular problem, that then we can write the code inside that function. And what does it mean the function is calling the same function again, which is we called it recursion actually. This means that this function we are calling with some other input or might be the same input as well. So this is just a recursion. So recursion is not only ends over there. We have the two important things that we need remember while solving any recursion problem. One thing that we need to remember is that what the return type that we need to have, and second thing is that base condition. So we will understand this return type when I'm going through the example. Let's understand the base condition first. Base condition is used to stop the recursion because eventually we want the answer from this function. Don't want that it is calling the same function again and again and there is an infinite loop that never going to end. How this is never going to end? Let me just give you an example. Suppose we have the function and we are passing the input as 9. Suppose we are calling that function, we are passing the input as 9. So we need to write the definition of the function. Suppose we have this I and it is just a pseudocode. Inside it, we are calling the same function as I minus 1. So it is never going to end. Why? Because 9 will be supplied over there and then 8 will be supplied over there. F is again being called with f of 8 and then again it will continue up to minus infinity. So we need something so that it could stop. Our base condition could be, we could write the base condition as is equals to 0, then we could return 0. What will happen now is that if we supply the input 9 to this function, it is I minus 1 which has become 8. Now it again call the function with the input f of 8, becomes 8 because we are passing as the parameter of I minus 1 and then 7 and then 6. At some point I becomes 0. So if we place this particular condition before this function call, then if I condition is been satisfied, then we are going to return 0. Then it will not going to call this function below 0. It is not going to subtract it. That's why it is acting as a base condition. So we have understood two things. So in the recursion problem, we have to understand about the what is the return type that we need to take, and second thing is that what is the base condition that we need to provide to stop the function. So this will constitute our recursion, and recursion is just to call the same function again and again. Why this is required? First of all, recursion is very important to reduce the size of the code. When you were doing the tree traversal in the iterative manner, then it might takes you the 100 lines of the code. But if you do it in the recursion, it rarely takes 4 or 5 lines of code. So that's the power of recursion. So recursion used to solve the complex problem in the easy manner. And so after this we are going to solve one of the basic example of the recursion. So yeah, so if you were asked to calculate the sum of n elements, suppose you were given the number of n is equals to 8, right? Or maybe take some 4, a smaller number, suppose. Then you were asked to calculate the sum of n elements and you were given the value of n as 4. Then what you will do? So you might say that yeah, so we already had the formula for it to calculate the sum of n elements. Yeah, that would work because we supply the value 4 into 5 by 2, which is 2, which is 10. Yeah, it is working perfectly fine. But if it is being asked to calculate the with the use of the recursion, then how you are going to do that? And this is the basic example to understand the recursion as well. The main intention here to not solve this question using recursion, but basically to understand the recursion. If we are good in applying the recursion where we can apply it, then that's the skill that we actually need to learn. We need to write the function. So we write the function, and what we have is basically the value of n is the input that we are provided with. So to solve the recursion problem, first we need the function, and in recursion we require the two things. First of all, the return type, and second is basically the base condition. So we know that what input we need to supply and what is the return type. So it is the sum that we need to output. Return type will be the int, and how we are going to return it, that is also the most important thing. So in this function we are going to find the sum of all these four numbers. So let's try to understand what recursion is doing. Recursion is basically trying to reduce the problem. So we have the problem to find the sum of four numbers. What if we try to divide this problem to find the sum of three numbers? How we can do this is basically, if we can find the sum of these three numbers and try to add 4 in this, this will give us the answer of sum of four numbers. So we are trying to find the sum of four numbers. What we do is basically we add 4, which is n, and we do the sum of three numbers. If we try to add the same, we will get this answer. So we are basically reusing the same function. In general, we could write this as f of n plus f of n minus 1. So this basically holds true. So we have generalized our function, and this will work for any n, even if we have the 100 numbers. So if we have 100, if we supply this 100 and try to add 100 in the sum of the 99 numbers, it will give me the sum of 100 numbers, because this is the same thing that we are doing. We are just adding the numbers. So yeah, so this is called the recursion equation. This will be used to calculate the time complexity as well, that we are going to see it in the later videos, but here our intention to learn the recursion. So yeah, so we have collected that how we are going to do the recursion. So how recursion is being used here is that this particular function is calling the same function but with the reduced input. So try to write this function. So I'm writing this function as n plus f of n minus 1. As I've said that we need to return it because we actually need the answer as well. So will this work or not? Actually, this is not going to work to the infinite loop here, because there is no base condition. So no one is stopping that particular function at a particular point, as I have already explained you earlier as well. So to stop this particular function, so what will happen if we are just out of numbers, right? So we are starting from the 1 2 3 4. If we reach to this particular position, so we don't have anything to add. We can add it with 1. So what we can do, either we can choose it n is equals to 1 or n is equals to 0. So we can write our base condition as if n is equals to 1, we can return. So this will work actually. So and this function is calling the same function. So yeah, so let me just tell you like how this recursion is happening internally inside the memory, how the memory is being allocated to a particular function. Or so let's understand this. What we have in the computer memory is that we have the stack actually, so which is the part of the computer memory. What happens is that when we call a certain function with a certain input, one block of the memory is being allocated in one function call. Suppose we call the function with the input as 4. So what happens is that we write over there as f of 4, and then it execute the lines of the code. It will check over there this if condition. So I will write 1 over there and I will write 2 over there. So it will first execute the 1, and then it will then execute the 2. So in the 2 it will first write the 4, and then it will again make the function call of f of 3. What function is doing over there? We have seen the addition of the variables like a plus b, but what function is doing over there? So that function value is being replaced by the value what function is returning. So what value the function it will return, it will be replaced by its return value. We will see over there like what value it is going to return. So then it is making the function call f of 3. Then what it will do, it will again allocate the memory for f of 3, because another block of the function will be allocated, because this f of 3 is nothing, it will make the call of the same function again. Then it will again execute the 1, it will not satisfy, then it will again execute the 2, then it will again call the f of 2 with the input f of 2, and then same will be allocated for f of 2, same process will be happen for f of 1. Then what will happen for f of 1? It will first execute the first statement, and then it is satisfying the condition where it is returning something. First of all, that block has been created for that particular function, and once it returns the value, first of all, f of 1 is being called from f of 2. So first it will execute the 1, and then it will execute the 2, where it will write 2 plus f of 1. So it is calling the f of 1 from over there, because f of 1 is not being called from f of 3, right? So it is being returned over there. That's the meaning of the return statement. That's what I am saying, that this function value is being replaced by its return value. So we are returning the 1, this means that it has been replaced by 3. And what f of 2 is doing, so it is also returning this value. So 3 is being returned over there and replaced by f of 2. So what it is doing, 3 plus 3, and then it is again returning the value. So 6 will be returned over there, and 6 plus 4 is 10, and then it has been returned to its actual calling function, which we are calling it from the main. That's how it is being solved internally. Once inside the function, when any value is being returned, this block of memory will be destroyed. So this is destroyed, this is destroyed, this is destroyed, right? So space complexity is about how much space this function is taking while its execution. It depends upon how many function calls are there. So currently there are n function calls. Suppose if the input is n is equals to 100, then at maximum, so 100 function calls will be created in the stack, and one by one it will be destroyed. But at maximum is 100 blocks of the memory, which is directly proportional what is the input size of the function. So although it is an internal space, we are not creating the array over there, or we are not creating the 100 variables depending upon the input. We are just using the internal space. So it is an internal space. So you might ask that every time we have to solve this recursion question, do we need to create and visualize this diagram? Because initially you can draw this diagram for the better understanding. So what you can do to visualize this function calls, that how the function calls are being made with the reduced input. So what you can do is that so suppose the function call is being made with f of 4 input. It will basically call this function again. Like you can do something like it is being again called with the function of f of 3. 3 is being added, because eventually this particular thing is needs to be returned, right? After adding with the return value of f of 3, and then it will again make f of 2, and then yeah, so 2 plus f of 1, then f of 1 is being called. So our this condition will be satisfied over there, and it will directly return 1, and then the result of this will be returned to this, which is 3. The result of this addition will be returned as 6, and the result of this will be passed to it, which is 10, and which is the correct answer. So this is the best practice that I use, and it is very easy to determine. And later there might be the some more function calls. Suppose you are doing the n minus 1, and in some other question you might be doing n minus 2 as well, right? It will do just add the function call over there. Suppose you are making the function call, now you are making the two function call with f of 2 and with f of 3, and you are trying to add them, and you also need to add the 4 with them. Again the same process will be followed, f of 2, f of 1, same, you need to add the 3 with them. So this is how the complexity can be increased with the recursion also. So we can see that how simple is the recursion, and in just 2-3 lines we can solve this question. And it is not just with this question, we can solve even the complex question with the use of the recursion, which is very important. It is just a basic video, and I will try to put many other videos for the recursion if you really want this. I hope you really like this video. I think I have covered everything that you need to require to understand the recursion, and what you need to do it now. You can just go to the lead, try to do as many as problem you can do for the recursion, either easy or the medium portion. And if you find any other problem, let me know in the comment section that which problem you might be facing the issue with. I will try to put that video for you as well. So let's end this video. Till then, bye bye.